Hi everyone, welcome to another video. And in this video, I'll be solving some Leetcode problems. Mm, And yeah, this is part 22. Every day I solve few problems. Not like every day, whenever I have time. So I'm so proud of myself and glad that I've been able to get till here and make my videos be here till part 22. I think that's pretty exciting when you start and when you're learning something new and you're documenting it. So it could show you how far you've come. So, yeah, let's get started. Okay, so this problem is 6 of 5 can place flowers. You have a long flower bed in which some of the plots are planted and some are not. However, flowers cannot be planted in adjacent plots. So we want to plant in a flower bed or garden, but we cannot plant it one beside other or adjacently. Given an integer array flower bed containing zeros and ones, where 0 means empty and 1 means not empty, and an integer n, our goal is to return true if n new flowers can be planted in flower bed without violating the no adjacent flower rules and false otherwise. Let's look at the example. Here we have flower bed 1 0 0 1 n equal to 1. If I place this 1 here, then it will make sure that it is not adjacent and all flowers are planted as well. That is why the output is 2. Also, uh, here it's false. But difference of 2 would put 1 here and like these would make it adjacent, so output is false. So let's write what all we know. We are given flower bed of 0 equal to 0. This means it's an empty plot. Flower bed of were already planted. The rule is no two adjacent flowers can be placed beside one another. And our goal is to determine whether we can plant any new flowers without breaking the rule. For example, flower bed is 10001 and n equal to 1. So possible planting will become 101 and output equal to 2 as it's not adjacent. So can plant a flower at index I only if flower bed of I is empty first. It is an empty plot and left neighbor is 0 and right neighbor is 0. So these three conditions should be met, I feel. If it is true, then we can plant flower, increment count, update flower bed to 1. A brute force idea would be to try all possible combinations of placing flowers, but in this case, the combinations grow exponentially and time complexity becomes O of 2 to the power n. An optimal approach would be to use greedy idea. So whenever plot is safe, we can plant a flower immediately. Plotting early will never reduce future possibilities. So yeah, this is my idea so far. Let me we are given flower bed which is in form of list and an integer n. A walkthrough would be like if our input is in this place, left is also 0, right is also 0, so we can plant here. is the walkthrough. So we can plant here because adjacent neighbors are 0. So count becomes 1. Thinking about time complexity, we are scanning so it becomes O of n space complexity is constant. So what I'm doing on a high level is I'm iterating the flower bed and checking if a flower can be planted at each position. A flower can be planted if the current plot is empty and neighboring both neighboring plots are empty or out of bounds. So when a valid spot is found, I will plant a flower. Can plant a flower and increment the count. Finally, I can check if the number of planted flowers is at least 1. Sorry, is at least n. At least n. I think this pattern is called greedy placement pattern, where we are placing an item as early as possible. So the local optimal takes us to the global optimal. Hi, frozen chicken. Nice username, but I think that would lead to more time complexity, I believe. I'll try to submit this, run this first. Runtime error. Okay. Maybe that could be a new solution, I guess. Let's see what I can have the next problem as. Take a super easy one. This is called. Okay. So this is also, I think, okay problem. We are given a binary array nums. Need to return the maximum number of consecutive ones in the array. For example, an example one, maximum number of consecutive ones is this, so 3. First two digits or the last three digits are consecutive ones, but the maximum number of consecutive ones is this 3. In here, it is consecutive ones is 2. So we are given a binary array with 1, 3 presents, 2, and 0. Basically breaks our sequence. Our goal is to return the maximum number of consecutive ones in the array. So, for example, if our nums is 1, 1, 0, 1, 1, 1, then sequence of ones are like 2. This could be of length 2 and is of length 3. Max between both is 3, which can be the output. The key idea is we can track two variables. Maybe if we have first variable as the current count, should track current streak of ones. Next will be max count. Maximum streak seen so far. So if nums of I equal to 1, If the number is 1, we increment the count. Then we can update max count. Else can reset current count to 0. A brute force approach will be to check every sub-array and then check if it contains only one. So in brute force and then track maximum length, but this will be time complexity of O(n) square. An optimal approach will be to maintain a running count consecutive ones. We reset when encounter 0. So we are given nums in the form of list. Let's declare a variable called max count to keep the running count. Then another variable called current count. For num in the list nums, if num is 1, then we increment the current count. And then the max count becomes max of count comma current count. Else current count becomes 0. Here we are resetting. Then finally we can return max count. Time complexity O of n as we are scanning array once. Space complexity will be O of 1. No extra variables used. Okay, so finally can say I am iterating to the array while maintaining a running count consecutive ones. If I encounter a 1, I increment the count and update the maximum streak. Seen so far, if I encounter a 0, I reset current count as our streak of ones is broken. This is this pattern is running count or streak pattern. Let me try and run this. Yeah, I mean, it depends on the job description as well. And initially, they ask if you want to use Python or Java or what. So I think they should be. It should be allowed. Mhm. I've been practicing in Python only. Okay, moving on. This problem is called 860 lemonade, number 860 lemonade change. Let's read it. It says at a lemonade stand, each lemonade costs $5. Customers are standing in a queue to buy from you and order one at a time in the order specified by bills. Each customer will only buy one lemonade and pay with either a $5, $10, or a $20 bill. You must provide the correct change to each customer so that the net transaction is that the customer pays $5. Note that you do not have any change in hand at first. So, given an integer array bills, where bill suffice the bill the ith customer pays, return true if you can provide every customer with correct change or false otherwise. So this is bills and these are what customer 1, 2, 3, 4, 5 gave us. So from first three customers we collect three $5 bills in order. From the fourth customer we collect a $10 bill and we give back $5 to him. From the fifth customer we give a $10 bill and a $5 bill back to him. So $15 we can give him back. Since all customers got correct change, we out to here fun here first to customer we collect two $5 bills. For next to customer we collect a $10 bill and give back $5. For last customer we cannot get give the change of $15 back because we just only have two $10. Since not every customer received the correct change, the answer is false. Okay. So we need to make sure after taking from every customer, we are returning the correct change for a particular lemonade. So I'll write down what all we are given. We run a lemonade stand. Each lemonade costs $5. Customer pays using $5 bill, $10 bill, or $20 bill. We must give the correct change initially give back. We have no money. Our goal is to return true if we can give correct change to every customer, otherwise false. So, for example, if our bills array is 5, 5, 5, and 20, then customer 1 pays $5 and gets $0 change. customer 3 is also sent, but for customer 4, he pays $1 and gets back $5 as change because lemonade costs. The key idea is we need to track how many $5 bills and $10 bills we have. How do we decide the combination? So if I have, I'll make a variable called 5 to denote number of $5 bills. Then I'll make another variable called 10 to denote number of $10 bills. If the customer pays just $5, then clearly no change needed, and we can increment if the customer pays $10, we must give $5 change. 5 equal to 5 becomes a $5 bill goes back to him. $10 increments. Because we took $10 bill from him and returned 5, so 5 becomes 1 minus. If the customer is $20 and we must give $15 change back to him. But to give $15 change, there could be two possibilities basically. Either we can do one case would be either we can give $10 and then $5. I think this is the best option. Another case would be to give $5 with $5. But yeah, this is like kind of greedy choice as we want to preserve $5. So a brute force idea would be to try all possible combinations of given change. This will explode the time complexity can be exponential O2 to the power n. An optimal solution would be greedy approach. You can process customers sequentially, always give change using first else. This will preserve smaller bills for future customers. So yeah, we are given bills which is in the form of list and we need to return true or false. So I'm gonna make a variable 5. For bill and bills. We're taking this case. If bill equal to 5, 5 equal to 5 plus 1. The customer pays 20, we must give $15 change back. If bill is 50, so we did that, we need 10 and $5 back, right? Give back that. Decrement $10 bill because we are giving and returning back from the $10 we already have. 10 minus 1. So one $10 goes to him and one $5 also goes to LF. Also, if we have equal to, if we have three $5 bills or more than three $5 bills, hmm, I'm just trying to put my thoughts in the form of comments, like just imagining if what would happen if it's like in real happening in real life. If somebody's buying lemonade from you for $5 and pattern is because I'm learning about it like patterns in my master's course, so kind of have an idea for that, like okay this pattern is being used. But in general also there are some YouTube videos where if you go and search in the YouTube bar top 15 patterns used in every lead code problem, so you will find the answer or videos they explain that okay, this pattern is mostly used, so you can check. But I think of brute force and then move to optimal and then think of time and space complexity. नहीं, मैं सी सीपीपी में सॉल्व नहीं करती, सी में, पाइथन में ही स्टार्टिंग से कर रही हूँ। I'm currently in class 8. I have very much interest in codings. That's nice. You're so early and young. Class 8. I would say keep going. तुम्हारा ट्रैक सही है already. HTML, CSS, JS, Next.js. Try to make projects, build your portfolio website, hobby website, and I think that would be interesting. I think तुम्हारे ऊपर है, whichever is feel easy. I'm comfortable in Python. I think try with Python and Java, I think, if you would like. Okay, I'll take another easy problem. Oh, I did not check the daily problem for today. Okay, moving on. This is squares of a sorted array. So you are given an integer array nums sorted in non-decreasing order. We need to return an array of the squares of each number sorted in non-decreasing order. So if our input nums is this, it also has some negative numbers. We will first sort it. So 0 will come in first. This will come in first. Oh, this is already sorted actually. Output becomes this. After squaring, the array becomes 16. 4 square 16, 1 square 1, 0 square 0, 3 square 9, 10 square 100. And then we sort it. Becomes 0, 1, 9, 1600. 7 square 49, 3 square 9. Okay. And sorted array. For example, if our nums is so if our nums is -4, -1, 0, 3, 10, and squares would be 16, 1, 0, 9, and then 100. Sorting it will become 0, 1, 9, 16, and 100 because we made it from increase to decreasing. Sorry, decrease smallest to largest. But here it is sorted by value, not by absolute value. So there are negative numbers as well. So we need to handle that case. Like if our if our nums is it's absolute, we will become absolute values. We are converting negative to positive as well. So that is what absolute value is. So I'm picking absolute value. It will become 7, 3, 2, 3, 11. And then in this case, the largest square may come from either the left side or the right side. Like what I mean is that -7 square and 11 square is 121. So we need to compare absolute values rather than just the values, because we need to handle the negative numbers as well, and that should happen at both the ends. The complete force approach will be to square all the numbers, sort the array, but this in total will give us over n log n. See, time complexity. Another optimal approach will be using, as we need to check on both the ends, left and right, we'll be using two pointers. Since the largest square come from the ends, we can use two pointers. Compare absolute values. Here is the larger square. So we can have like two pointers. We left pointer will point the start of the array. Here will be right pointer, which will point to the end of the array. And we can have another variable called position, which will be last index of the result. What are we given? We are given nums list. We need to return list as well. The left pointer is smaller than the right pointer. We can take absolute values. the indentation. Should be okay. Since the array is sorted, but negative numbers can any day produce like larger square, the largest square will come from the either end of the array. So that's why we thought of using two pointers in this problem. I try using pointers at the compare absolute values, place the larger square at the end of the array. Then I move the corresponding pointer inward. This is so I use the operator. It's such a simple step. Bitwiser. Yeah, this is where right. I use the English notation for it. Damn, silly mistake. Okay, now better. I was trying to solve one thing. That is why I was not speaking, but I speak. Like if you go to the back of my video, I do. Okay. I have like one problem left, and then I'll end the stream. Okay, so this is problem number 1051 height checker. Let's read it. Okay. A school is trying to take annual photo of all the students. The students are asked to stand in a single file line in non-decreasing order by height. Let this ordering be represented by integer are expected, where expected of I is the expected height of ith student in the line. You are given an integer array heights representing the current order that the students are standing in. Each height of I is the height of the ith student in the line. We need to return the number of indices where height of I is not equal to expected of I. Okay. So students are lining up and they are in non-decreasing order, but you need to check the number of positions where it's not the desired one on how they should stand. So if this is the height array, so height is 114213. Then we sort it. So this is the expected from smallest to the largest. But we can then compare the indices. Here it is not matching. So this student is incorrectly standing. This student is incorrectly standing. This also. So indices 2, 4, and 5 don't match because there's 0, 1, 2, 3, 4, 5. So 2, 4, and 5 do not match. It's 5, 1, 2, 3, 4. Then expected we sort it and check. Nobody's standing at the right position, so all indices do not match. Then here we have height. When we sort it, everybody's standing at the right position, so all indices match. Just keep practicing and applying. अभी तो थोड़ा कॉम्पिटिटिव हो ही गया है हर जगह पे. Okay, so let's write down what all we are given. Current order of students. Students should stand in non-decreasing order of height. So we create expected sorted version of heights. Our goal is to count how many indices where height of I is not equal to expected of I. Example, if our heights is 114,213, then we sort it. Expected highest, and this will be sorted. So 1, 1, 1, 2, 3, 4. And we compare index 0. At index 0, height is equal to 1 and expected equal to 1. Both match. At index 4, what do we have? 0, 1, 2, 3, 4, 1 and 3. Heights equal to 1, expected equal to 3. So 3 of them have difference. Brute force idea. We will try to determine the correct position of each student by comparing with every other height. This will be really slow, like bone and square. An optimal approach will be to copy the array first and then sort the copied array. Compare both array index by index. Count the number of mismatches. So I'm gonna do open import list, and then I'll create a copy first. Use the sorted function to sort the given heights. I'll keep a count variable. First initialize it to 0. Then for I in range length from 0 to length of till the end of the array heights array. If heights of I is not equal to expected of y, increment the count, and then finally we can return count. Of n log n. Space complexity is of n. This is because of sorting. Add a copy for sorting. I created a sorted version of the heights array to represent the expected order, and then I iterate through both the arrays and count the indices where the values differ. This will gives me the number standing in the wrong position, and then I return the count position students. This sorting is comparison pattern. I think I've solved, I don't know, 160 problems. I've been solving since January. No, actually started in January. I had experience because I took algorithms as a subject. So I have few idea for 6 months. So yeah, okay, let's submit this, and this is the final problem. I'll end the stream after this. So this is correct. Um, I'm gonna get some hot chocolate or coffee after this. I'm feeling sleepy. Okay, good, good, good. So this is also done. We kind of have an idea on brute force and optimal approach now. Okay, I think it's good time to end this stream now and take a break. I'm gonna grab a hot chocolate or something. Okay, guys, bye. Thank you for joining. See you tomorrow or whenever I join again. The best feeling is when you close all the tabs.